Okay, we just learned about related rates. Related rates are problems that have more than one variable, and we're taking the derivative of those variables with respect to the same variable. And usually we're taking the derivative with respect to time. So let's jump in and do this first problem. This first problem has a typo, actually. It says to find dy dt of the relation y squared equals 3x squared plus 6x. And we want to find that when x equals 1 and dx dt equals 2. All right, the fact that this gives us dy dt, that tells us we're taking the derivative of this with respect to time. All right, let's look at what we have. We have y squared, so I'm going to write this as y of t squared equals 3x to the fourth, but I'm going to write this as x of t to the fourth plus 6 times x of t. Now, for the y of t and x of t, we need to treat this as a composite function, so we're going to take the derivative using the chain rule. So if I have y of t squared, the derivative is going to be the derivative of the inside, which is y prime of t, times the derivative of the outside. Well, the 2 comes out in front, and I get 2 times y of t, and then I'm going to subtract 1 from the exponent, which is just going to be 1. So now, to write this so it's visually a little bit easier to see, I'm going to rewrite y prime of t as dy dt. And then I'll just keep the rest the same for now. So my left-hand side of the equation becomes dy dt times 2 times y of t. All right, the right-hand side becomes, well, the 3 stays there, and then I have x of t all raised to the 4th power. I'm going to find the derivative of this using the chain rule. For the chain rule, we find the derivative of the inside, which is just x prime of t, times the derivative of the outside. Well, the 4 comes out in front, and I'm going to multiply it by x of t. The inside stays the same, and then I'm going to subtract 1 from the exponent. That is the power rule. Now I'm going to rewrite this x prime of t as dx dt, then times 4 x of t cubed. So that term becomes, the 3 still stays there, times dx dt times 4 times x of t. And then by the same notion, I'm going to find the derivative of 6x of t. This is just going to be 6 times dx dt. Now, what are we solving for? I'm going to solve for dy dt, and I can rewrite this whole thing with dy dt on one side, but if I plug in numbers, it's probably just about the same amount of work. Let's see all the things I have. I have dx dt, so that's going to take care of these 2. And then I have x equals 1, so that'll take care of this x of t. But I don't have y of t. But I do have this equation. And I do know what x is, so I can figure out y. So y squared equals 3 times 1 to the 4th plus 6 times 1. That's going to be y squared equals 9. So that tells us that we have y equals plus or minus 3. So I have all the pieces now. This is going to be plus or minus 3. So dy dt times 2 times, I'm just going to go ahead and use the positive 3 since I don't really have a context for this problem. Equals 3 times dx dt, that's going to be the 2 given the problem statement, times 4 times x cubed is going to be 1 cubed, plus 6, and then the dx dt is 2. So I get dy dt times 6 equals 36. So this means that dy dt equals 6. So that is example 1 for related rates.